Hello everyone, I hope you are all well. In this video, we are going to be looking at indices. So the learning intention is to be able to use index notation and work with indices. So by the end of this video, you will know how to add powers when multiplying expressions and take away powers when dividing expressions. Now let's first look at what we mean by index notation. So index notation, or using indices, helps us write repeated multiplication in a shorter way. So suppose we have 2 squared. You know that 2 squared is the same as 2 times 2. Okay, so 2 times 2, a shorter way of writing 2 times 2 is 2 squared. 2 cubed, that is equal to 2 times 2 times 2. Okay, so a shorter way of writing 2 times 2 times 2 is 2 cubed. Similar with 2 to the power of 4, this is the same as doing 2 times 2 times 2 times 2. So a quicker way of writing 2 times 2 times 2 times 2 is 2 to the power of 4. So then in our next example, we've got 5 times 5 times 5 times 5 times 5 times 5. So 6 5s are being multiplied together. So a shorter way of writing that is 5 to the power of 6. Okay. Then we've got a times a times a times a. We've got 4 a's here. So a shorthand way of writing that is a to the power of 4. And then finally we have -1 times -1 times -1. So we've got 3 negative 1s being multiplied together. So we write this as -1 to the power of 3. Okay, so those numbers here, so we've got 2 squared, 2 cubed, 2 to the power of 4, 5 to the power of 6, a to the power of 4, and -1 cubed. Those are what we call indices. Okay, so the number that's being raised in the corner, we call these indices. And then the 2's that we've got here, and the 5 and the a and the -1, we call this the base. Okay, so if you think back to our first success criteria, being able to add indices when multiplying expressions, this is what we're going to do now. Okay, so I've got few examples here. First one being 2 cubed times 2 to the power of 4. Okay, so remember, when we're multiplying expressions, we're adding the powers. So in the first example, well, we know that 2 cubed is the same as 2 times 2 times 2. Then we've got 2 to the power of 4, so that's times 2 times 2 times 2 times 2, so another 4 2's. Then that is the same as 2 to the power of 7. Okay, because in total we've got 7 2's. Okay, so instead of writing this all out, we can write it in the short way, 2 to the power of 7, and we know how to do that because when we're multiplying expressions, we are adding the powers together. Okay, so let's do the second one. We've got 3 squared. 3 squared is the same as 3 times 3. Then we've got 3 cubed, so I'm doing times 3 times 3 times 3. So in total we've got 1, 2, 3, 4, 5 3's. So then that is equal to 3 to the power of 5. Okay, and the last one, because we know the rule of when multiplying expressions, we just add the powers together. So instead of doing this middle step, I know that a cubed times a to the power of 4 will be equal to a to the power of 7. Okay, so we're adding the indices together when we're multiplying the expression. So rule 1, when we multiply expressions containing the same base, okay, so the base here, we've got a as the base, we add the indices. So the indices are m and n. Okay, so a to the power of m times a to the power of n is equal to a to the power of m plus n. So that's your first success criteria. Okay, now let's have a look at the second success criteria. When we're dividing, we're now going to be dividing expressions. Okay, and in the second success criteria, we're told that when we divide expressions, we take away the indices. Okay, so in this first example, we've got 7 to the power of 5. So that's the same as 7 times 7 times 7, times 7 times 7. 5 sevens at the top, and at the bottom we've got 7 squared, so that's the same as 7 times 7. Okay, so then each of the 7 at the top will cancel out 1 at the bottom, because 7 divided by 7 is 1. So we've got 2 at the bottom, so we just cancel 2 at the top. So then we're left with 3 sevens at the top of the fraction in our numerator. So then that is equal to 7 cubed. Okay, now we could have skipped this step here, because we know that when we're dividing expressions, we just take away the powers. So we did 5 take away 2 to get the 3. Okay, so in this example, we've got b to the power of 5 divided by b to the power of negative 2. Okay, so remember our rule for dividing expressions, we take away the indices. So we would have b to the power of 5 take away negative 2. Okay, so we've got 5 take away negative 2. So then that is then equal to 5 plus 2, which is 7. So the answer to this one is b to the power of 7. In the third example, we've got x to the power of 4 divided by x cubed. So then our answer is x to the power of, well, we're doing 4 take away 3, so it's the power of 1. Okay, and that is just the same as writing x, because we've only got one x, so x to the power of 1 is just x. And in the final example, we've got 8y to the power of 7 divided by 4y to the power of 5. So in this fraction, we've got 8, we first do 8 divided by 4, that is equal to 2. Then we do y to the power of 7 divided by y to the power of 5, which is equal to y to the power of 2, because 7 take away 5 is 2. So your final answer is 2y squared. Okay, so that is our rule number 2. When we divide expressions containing the same base, we subtract the indices. So here we've got a to the power of m divided by a to the power of n, which is equal to a to the power of m minus n. Okay, so those are your 2 rules there. So remember, when you multiply expressions, you're adding the indices, and when you're dividing expressions, you're taking away the indices.